All right, with problem number 4, let's see if we can get another screen here. And worksheet 4 answers and arts. Oh, no, this is worksheet 5, right? Worksheet 5. And it says, we're allowed to use the unit circle, so maybe we'll try to use it a little bit. But there is a way to do these problems without using the unit circle, so maybe we'll also do some of them without it. So let's see. Given angle theta in standard position, find the coordinates of the associated point on the unit circle in exact form. Okay, so yeah, let's go ahead and start with one of these problems. First of all, the unit circle is a circle of radius 1 unit, right? So here's length 1. Let's see, how can I draw a perfect circle? Oop, there's one there. Mhm. Okay, so this circle has a radius of 1. And so maybe I should put a negative here on that side. And so we're going to study the sine and cosine, not of just random angles like in problem number 3 that we just did, but we want to look at the sine, cosine, tangent of a few angles that are on the unit circle, 30, 45, 60 degrees, and so on. And so the way to do that is, one way to do that is through the use of this unit circle. So let's take a look at 3 pi over 2 for a moment, and we'll kind of explain the process. Um, and then, you know what? Actually, that's not the best example. Let us use, um, how about, yeah, let's use, we'll do this problem in a moment, but how about we use the angle theta equals 45 degrees is a pretty good one. Okay, so 45 degrees, let's say we want to find the sine of 45 degrees, meaning we want to know what is the opposite side length divided by the hypotenuse length in a 45-degree angle. Well, we can draw the angle here, and this side will terminate at the unit circle. It turns out that the unit circle can give us the sine of 45 degrees just by looking at the coordinates of where this terminating side intersects with the unit circle. We can draw a triangle using that 45-degree angle, and then dropping down a perpendicular, there's my dashed line that is perpendicular to the positive x-axis. And so we know that this is 45 degrees. If you remember from geometry, the three angles in any triangle actually have to add up to 180 degrees. So that tells us that this angle here must also be 45 degrees in order for them to add up to 180. And so what are the side lengths of this triangle here? Well, since we have a circle that has a radius of 1, and this hypotenuse is the radius of the circle, then that side length there must be equal to 1. The hypotenuse must have length 1. And the other two sides, we're going to say are of length x. This side length here, I don't know what it is. And this side length here, since the angle opposite each of these side lengths is 45 degrees for both, Both of these sides are actually going to have the same length. This is called an equilateral triangle. Sorry, isosceles triangle. Getting my terms mixed up here. And so we can use the Pythagorean theorem to find out what x must be equal to. So leg squared plus the other leg squared is equal to the hypotenuse squared. So this gives me 2x squared equals 1. Dividing by 2 on both sides, I get x squared is equal to 1/2. And taking the square root gives me that x is equal to the square root of 1 over the square root of 2. And this is equal to, the square root of 1 is 1. The square root of 2 is just, we can't really simplify that too much, so we'll leave it as a square root of 2. And then we can rationalize the denominator, meaning we don't want to have a radical in the denominator. So I can multiply by the square root of 2 over the square root of 2. And this is going to give me 1 times the square root of 2 on top is just the square root of 2. On the bottom, I have the square root of 2 times the square root of 2, which is the square root of 4. And we all know what the square root of 4 is. That is just 2. And so, okay, quite a bit of work there. But what we've shown is what we've shown there is that the coordinates of this point here are in the x direction, the square root of 2 over 2. That's this direction here. And then how much do we go up? Well, it turns out that the amount that we go up is also the square root of 2 over 2. So those are the coordinates of this point here. And let's now find the sine of this 45-degree angle, which I'll mark here with these 2 marks. Sine of 45 degrees is, remember, opposite over hypotenuse. And so the sine of 45 degrees ends up coming out to be the opposite side length, square root of 2 over 2, that's this x value, divided by the hypotenuse, which is 1. And if I divide those 2 numbers, any number divided by 1 is just itself. The sine of the angle theta ends up being just this vertical value here, which is the square root of 2 over 2. That number there. Now we can actually generalize this and say, well, in general, let's draw another angle. How about we use green over here? And let's call this angle, well, let me use an angle, a nice angle here. So let me copy that and just paste in your copy. Okay. Now let's choose another angle, and I'm going to choose it in the first quadrant for right now, just some random angle. For some random angle made in quadrant 1, I can repeat this process and say, okay, well, my angle that I'm considering is theta, which is that angle there. And for now, I'm going to just leave this side length of the triangle, that small length there is x, and this vertical length I'm going to call y. And we know that the radius of this circle is 1, so the coordinates of this point on the unit circle are just going to be x comma y. And the sine of the angle theta is going to be opposite side length divided by the hypotenuse. So the sine of the angle theta is just going to be the y value, this value here. Okay. The cosine of the angle theta is going to be what? The adjacent side length divided by the hypotenuse, which is just going to be x. So if you're asked to find the cosine of some angle theta, that is just going to be that first coordinate there. Okay. If you wanted to find the tangent of theta, uh, yeah, let's go ahead and continue. We're actually getting into problem number 5 territory as well here. So we'll just make one video for problems 4 and 5. But the tangent of theta, how can we determine the tangent? Well, let's use tangent of theta is equal to opposite over adjacent. We can use that definition. And the opposite side length is y. The adjacent side length is x. So we have now redefined sine, cosine, and tangent instead of just using uh, adjacent, opposite, hypotenuse. We can define the sine of any angle theta in terms of x and y. So here are the definitions for sine, cosine, and tangent on the unit circle. We can continue here and give the cosecant of theta. This is the reciprocal of sine, so that would just be 1 over y. The secant of theta is equal to 1 over x, and the cotangent of theta is equal to x over y. Now, I should modify this a little bit, but actually, let's go ahead and complete problems 4 and 5 with these definitions, and then we will modify these definitions slightly to include cases where we're not working with a unit circle, but we're working with an arbitrary, circle of radius r. If our circle is of radius r, the difference is going to be, instead of these ones here, the hypotenuse is going to be of length of length r. And so these definitions change to, these marked in red here. So we'll mention that in just a moment, but for now, let's go ahead and jump into problem number 4. And it says, given an angle in standard position, find the coordinates of the associated point on the unit circle in exact form. Use the unit circle. Okay, so we'll go to the unit circle, and we want to find the angle, 3 pi over 2. Oh. And the associated point is this one here. And so that's the answer. This exercise is just to get us comfortable with finding the associated point. Now, we said that the x value is going to be the cosine of the angle, 3 pi over 2, and the y value is going to be the sine of the angle, 3 pi over 2. But for right now, we don't need to know that for this problem. All we need to do is find that associated point. So next, let's do part B. It says 225 degrees. All we have to do is go and find 225 degrees on our unit circle. And once we find 225, we go over here, and the associated point is our answer. That is negative root 2 over 2, comma, negative root 2 over 2. Okay. So next, negative 225 degrees. Well, that is going to be coterminal with, let's see, negative 225 degrees. If I add 360 to that, that's going to give me a coterminal angle. And so let's see, I need to do a little bit of arithmetic here. 360 minus 225, that is going to be 6, 5, 10, 5. 5 minus 2 is 3. 3 minus 2 is 1. 135 degrees. So keep in mind that we have negative 225 degrees. So that is going to be coterminal with 135 degrees. So just to point out where the angle is, um, that is going to be, starting here at there at 0 and then going in the negative direction 225 degrees to end up at 135 degrees here. And so there's roughly what the angle looks like. Now, what we care about in this problem is the associated point, which is going to be that one there. 135 degrees, its associated point. So negative 225, that would be negative square root 2 over 2, comma, square root 2 over 2. Now, I would actually like to show how to get this point without using the unit circle. I don't want to make this video too long, but it is a good exercise. And just to kind of give a little bit more terminology than what we've given so far, let's go back to our XY plane. And I'm just going to draw the first two. So here's the x-axis, the y-axis. This is what we call quadrant 1. Quadrant 2 is here. Quadrant 3 would be, quadrant 3 would be down here. And quadrant 4 would be here. So we said that we found out that negative 225 degrees was coterminal with 135 degrees, which is, the angle that I've drawn there, or at least the terminal side. And so if we wanted to try to determine what the x and y values were without using the unit circle, we could say, well, if this is 135 degrees, and we know that the x-axis, down here, if we drop down to the x-axis, that would be the 180-degree angle, then the difference in that is 45 degrees, right? 180 degrees minus 135 is 45. So that 45-degree angle has a name, and that is called the reference angle. The reference angle is 45 degrees for a negative 225-degree angle or the 135-degree angle. The reference angle is just the angle that is made with the x-axis using the terminal side of some other angle. So yeah, here I graphed a negative 225-degree angle. It terminates here with 135 degrees. And so the reference angle is just the angle that that terminal side makes, the smallest angle that the terminal side makes with the x-axis. Because somebody could try to say, well, what about over here? What's this angle? Well, the smaller of those two angles made with the x-axis is called the reference angle. So it's 45 degrees. And earlier, we said if we have a 45-degree angle, then if we're considering, that we are on the unit circle, this side length is going to be 1. Then the other two side lengths will be square root 2 over 2 and square root 2 over 2. This is what we found, when we solved for x earlier there, and the hypotenuse was of length 1. Okay, now the only thing that we need to modify here is that in the x direction, we are actually going in the negative x direction. So there should be a negative in front of the x coordinate. And notice that that's exactly negative root 2 over 2. That's exactly what the unit circle tells us there. The y value is square root 2 over 2. So this is the x value because it's along the x-axis. This is the y value. And we have our associated point without actually using the unit circle. Or at least, using this unit circle here to get them. So if you want to be able to do it without it, there is a way to do it without the unit circle. All right, negative 7 pi over 3. Oh, what is that? Okay, actually, we talked about this one earlier, right? Negative 7 pi over 3 was in a previous problem. 7 pi over 3 was actually, and that was coterminal with 60 degrees. Well, let's just do it here. So We'll do something similar to last time. We can use negative 6 pi over 3 uh, plus a negative pi over 3. That is negative 7 pi over 3. But this is negative 2 pi, right? So that's a complete rotation that we can almost kind of ignore because we know that our angle, negative 7 pi over 3, is coterminal with negative pi over 3. So if we go to the unit circle and we rotate pi over 3 radians, which is 60 degrees, in the negative direction, here is negative 7 pi over 3, or here's the coterminal angle. And so the associated point is this one here. So these answers are, they're very easy to find for the most part. There's not really too much work to do. A, B, C, D, E, F. Okay. 11 pi over 4. All right. Again, 11 pi over 4 is actually not on our unit circle. I'm going to convert this to degrees by multiplying by 180 degrees over pi. Let's see what we get here. Pi's cancel. 4, I'll cancel by 2. 2 goes into 4 2 times. 2 goes into 180 90 times. And 2 goes into 2 once, and 2 goes into 90. It'll divide it into 45. So if we multiply 45 degrees by 11, that gives us 495 degrees. And we notice that this is outside of the 0 to 360 degrees given on the unit circle. So we can subtract 360 degrees to find a coterminal angle. And that is 135 degrees. So the angle that we're looking for, 11 pi over 4, is coterminal with 135 degrees, which we've used earlier, so it's already highlighted. But the associated point is negative root 2 over 2, comma, root 2 over 2. Well, this is actually kind of cool here. Let's see. What's another way that we could have done this? We could have split this up. Maybe this will be even nicer to think about it this way, if you like fractions. 11 pi over 4 is the same as 8 pi over 4 plus 3 pi over 4. And 8 pi over 4 is just 2 pi. So we have a complete rotation and then 3 pi over 4 more radians. Here's 3 pi over 4, coterminal with 135 degrees. So it doesn't matter if you do it in degrees or in radians, we end up with the same answer. And then finally F, which is theta equals negative 5 pi. Well, negative 5 pi is the same as negative 2 pi, negative 2 pi, minus 2 pi, and minus 1 pi, or just minus pi. So, wow, this is a nice angle here. It is the angle that goes, since it's negative, it'll go clockwise. It goes 1 revolution, 2 revolutions, and then a half revolution, and ends up being coterminal with 180 degrees, or pi radians. So the associated point, the answer, is negative 1 comma 0. I'll box the answers in case it's not clear. Sometimes students get confused as to, that this is the answer here. It's not really much you got to do. Just have to find it on the unit circle. For some of these, you do have to kind of play around with the angle a little bit and find a coterminal angle, but it's not too complicated. All right. And then we'll do problem number 5 and then stop this video. So problem number 5 now asks us to find the cosine of an angle. Okay, and we said a moment ago that the cosine of theta on the unit circle is just the x value. And so problem number 4 asks us to find the associated point Problem number 5 asks us to find a trig function value, and we're going to use that associated point from problem number 4. So let's go ahead and try to find the cosine of 5 pi over 6. I'm going to write so here's 5 pi over 6 on the unit circle. The associated point, I'm going to write it down. It is negative root 3 over 2, comma 1/2. And so the cosine of theta is just the x value in that associated point. So again, if you have the unit circle, then the answer is just the x value, negative root 3 over 2. And it's nice and simple. The sine of, notice part B is actually the sine of the same angle. So the associated point is still the same one that I've written up above. The sine of an angle theta is just the y value. So the y value is 1/2. It's that value there. So there we go. Nice. Now we get to, yes, and just the reciprocal trig functions. So the cosecant of 150 degrees. Let me switch colors here. And let me delete a bunch of this stuff here in the unit circle. The cosecant of 150 degrees is equal to the reciprocal, or 1 over sine of 150 degrees. And we said earlier that the cosecant of theta was actually, since it's the reciprocal of sine, it would just be 1 over y, since sine is y. So let's go ahead and just say it's 1 over the y value. The y value being the y value of the associated point for 150 degrees. So the associated point is negative root 3 over 2, comma 1 over 2. The y value is 1/2, so 1 over 1/2 is just the reciprocal of 1/2, which is 2. And here I'll just write it down because sometimes that's 1 divided by 1/2, which is 1 times 2 over 1. 1 times 2 is 2. Nice. So, being given this associated point on the unit circle cuts down our work quite a bit. When I took this class, they didn't let me use the unit circle. I had to memorize a few triangles. And actually, I'll demonstrate that on the next one, just to show, maybe you saw that in your geometry class as well. So 150 degrees, when I was in this class here, I was told, okay, well, 150 degrees, you can find that. Then we make an angle, or make a triangle with the nearest part of the x-axis, which is this part here. Just drop a perpendicular line to the x-axis. And so this reference angle that we spoke of earlier, the difference in 150 to 180 is 30 degrees. So this is 30-degree reference angle. And here's where we have to introduce a new special right triangle. There's only really 2 of them. One of them was the 45-45 triangle that we spoke of earlier over here. So 45, 45, oops, what am I doing there? 45-degree angle, 45-degree angle. And one way that I learned this in my class was as, well, actually, I'll just use, root 2 over 2, root 2 over 2, and 1, right? We said these were the side lengths. And so let's go ahead and give the side lengths next for this 30, 60, 90 triangle. And if this is the 30-degree angle, this is the 60-degree angle, and this is 90. The side lengths are 1/2 root 3 over, actually, I'll do 1/2. The hypotenuse is of length 1. And then the third side length, you could use the Pythagorean theorem to find it. I'll just give it here. It is square root 3 over 2. So, I was asked to memorize this triangle. And it turns out that you can memorize not just this triangle, but you can actually, if you'd like, you can memorize any multiple of this triangle, any uh, constant multiple. And so we'd actually multiply all of these side lengths by 2. So it made it very easy to memorize the triangle side lengths, because if you multiply all the side lengths by 2, they become just 1, 2, and the square root of 3. And so it was almost like 1, 2, 3, but it was 1, 2, and then the square root of 3. Where the smallest side length here is 1, the square root of 3 is approximately 1.7. So the smallest side length was opposite the smallest angle. The next biggest angle is 60 degrees, which is opposite the next biggest side length, 1.7. And then, of course, the biggest angle here is the 90-degree angle, which is going to be opposite the longest side, which is of length 2. Okay, so you can memorize either of these two purple triangles. I will write them down here, square root 3 over 2, 1 over 2, and then 1. Since we are in the second quadrant, the x direction, we are going in the negative x direction. So my x value is negative, giving me an associated point of negative square root 3 over 2. That's the x value, and the y value of 1/2. Now here I'm teaching all of this stuff, so it's taking me a while to, it took me a while to come up with this just now, but if I was doing this problem on my own on a quiz or exam or something, I would have come up with it a lot quicker. And so now I can use this associated point or the cotangent definition that we gave up above. Cotangent was adjacent over opposite, right? So we can use cotangent is adjacent over opposite for this triangle that I drew in green. And so that would be, let's see, the adjacent side length is negative root 3 over 2. And then the opposite side length is 1 over 2. If I flip my fraction, my bottom fraction, and multiply, I end up with negative root 3. That is my answer. Now, I could have used this other definition as well. Cotangent of theta is equal to x over y. They're equivalent. The x value divided by the y value, that's exactly what I did. Okay. All right, and I know this video is getting a little bit long here, so I will just do this last two and wrap it up. So a lot of times, sometimes the angle, 5 pi over 6, 150 degrees, they show up on the unit circle. But what if our angle is something that does not show up on the unit circle? Well, we can find a coterminal angle and then find the secant or sine of that angle. So the secant of 29 pi over 6, 29 pi over 6, 29 pi over 6 is equal to 24 pi over 6 plus 5 pi over 6. And 24 pi over 6 is the same as, if I divide that, that's 4 pi plus 5 pi over 6, which is 4 pi is 2 pi plus 2 pi. So notice that we have two rotations, two full rotations that we can essentially ignore. And the terminating side of our 29 pi over 6 angle is going to end up at the exact same spot as the 5 pi over 6. So the secant of two coterminal angles are equal. And so the secant of 29 pi over 6 is equal to the same as this, or is equal to the secant of 5 pi over 6. Oh, and I never noticed, but all these problems are essentially referring to the same associated point. 5 pi over 6 we've already talked about here, and 5 pi over 6 is the same as 150 degrees. So we also talked about it in, yeah, parts A, B, C, and D. Okay, so our associated point is negative root 3 over 2, comma 1 over 2. And secant is just 1 over x by this definition here. So that's just 1 over the x coordinate, which is 1 over negative root 3 over 2. So that'd be negative 2 over root 3. And if we rationalize by multiplying by the square root that is on the bottom, and we have to multiply this on the bottom and the top, our answer is negative 2 root 3 over 3. Okay. Nice. And then finally, the tangent of negative 300 degrees. We'll do this without the unit circle, and then we will verify that we've done it correctly with the unit circle. So negative 300 degrees, where is that at? Okay, so here's 0. Here's negative 90, at the downward direction, negative 180, negative 270. And so if we go 30 more degrees, that would be negative 300 here. And so negative 300, if we're going in the negative direction, you can say a complete revolution would be to negative 360 degrees. So what is this angle here? This reference angle made with the x-axis, that would be a 60-degree reference angle. And that takes us back to our special triangle that has the 30-degree angle, and the other angle in there is 60 degrees, because 30 plus 60 is 90, and that plus the right angle of 90 is 180. So this is really just that angle that we worked with before, just kind of flipped around. Opposite the 60-degree angle, we had a side length of root 3 over 2. Opposite the 30-degree angle, we had a side length of 1 over 2, and the hypotenuse was length 1. So all we need to do is find the tangent of the 60-degree angle, because 60 degrees is coterminal, or sorry, yeah, 60 degrees is coterminal with negative 300 degrees, but we get a 60-degree reference angle using the negative 300-degree angle. So let me just say that one more time. If theta is equal to negative 300 degrees, we graphed it. Then we found out that the reference angle, which I'll call theta with the subscript of r, is 60 degrees. So if theta is negative 300 degrees, then the reference angle is 60 degrees. And it turns out that any trig function applied to the angle theta is going to be equal to that trig function applied to the reference angle theta sub r. Okay, so that tells us that the tangent of negative 300 degrees is the same as the tangent of its reference angle. Okay. See my longer videos for more, maybe more detail on that. Yeah, but okay, so yeah, let's go ahead and continue, and then we'll verify with a unit circle. Uh, Tangent is opposite over adjacent. So root 3 over 2 divided by 1 over 2. And if we flip and multiply, we get root 3. That is our answer. Now, if we try to verify with a unit circle, yeah, you're going to notice that negative 300 degrees is not on the unit circle. But if you rotate negative 300 degrees, you get to the same spot as the 60-degree angle. So the associated point is this one here. To find the tangent, you use y divided by x, and that would be root 3 over 2 divided by 1 over 2. And that's exactly what we did. Okay, so it's pretty easy there using the unit circle. So that's nice that we allow the use of the unit circle on quizzes and exams. So you can learn how to do those problems using that unit circle. But there is also a way to do it without it. I like to do the problems like that sometimes. Okay, so yeah, these are, so now we have the videos completed for problems 1 through 5, and we'll make videos for the rest of these problems as well.